We're on section 5.6 of your student journal, graphing linear inequalities in two variables. What is this, page 147? How can you graph a linear inequality? So really, inequality, your graph will look something like this, and the reason for that is because when you have an equation like y equals x plus 2, if I substitute 1 for x, the only thing I can get is 3. So there's only one output for my input. But for an inequality, you see this shaded area, you see all that shaded area, and that means all those are valid solutions. So, what does that mean? Let's just move on and I'll explain to you later. So, step one, they just listed out, graph the boundary line for the inequality. This is really simple. You basically treat it like an equation and you make a line. However, if there is just a lesser than or a greater than sign, you'll use a dashed line, so it will look like that. Or I could just go like this, boom, boom, boom. That's dashed. Use a solid line when there is an equal sign. So an easy way to visually understand this is when you see the equal sign, then your line will also have a solid line. If it is not, then it will not be a solid line. That's it. Test the point that is not on the boundary line. So you pick a spot above or below the line. When a test point is a solution, solution means it works. So when it works, shade the half plane that contains the point. That means it's right. If it works, it's right, and everything on that side is right. When the test point is not a solution, that means it does not work. You'd have to go in the opposite direction, because if it's wrong, then everything on the other side must be right. I'm sure all of this does not mean that much without giving you visual examples, so we will go into example time. So x plus y is greater than 5. Tell whether the ordered pair is a solution. So the reason why this is necessary to do is it helps you figure out which way to graph, or which way to shade in your graph. Sorry. So 3, this is x and y. 3 plus 2 is greater than 5. If it's a solution, whatever I say out loud will have to be true. So 5 is greater than 5. Is that true? No, it's not true because they are the same thing. They're equal to each other. So no, ordered pair is not a solution. For this one, again, don't forget that x is your first number. So we have 5 minus 3 is greater than or equal to 2. 2 is greater than or equal to 2. 2 is not equal then, but it is greater than, and it says an or, so it is, that part is true. So it's true. Yes, the ordered pair is a solution. That's it. You just go through this whole thing. You plug in whatever number, you substitute whatever number it tells you to substitute for x and y, and you say whether or not it's true. If it's true, then it's a solution. If it's not true, then it's not a solution. So -1 plus 2 times 2 is less than or equal to 4. -1 plus 4 is less than or equal to 4. 3 is less than or equal to 4. Yes, so this is a solution. So you guys can go ahead and do the rest of those. Graph the inequality in a coordinate plane. So the first thing you should see is that y is less than 4, and you should decide, oh, am I going to be doing a solid line or a dotted line? And since there is no equal line under the less than, then you know it's going to be dotted. And next we can, where is y? 4. So that's right here. Y is less than 4. So again, the y axis is up and down, vertical. So 1, 2, 3, 4. So this is where y is equal to 4. And I'm making the line, but the dashed line means it's not a solution. And it says less than, so if you think about the y values, 3 is less than 4, 2 is less than 4, 1 is less than 4, 0, and all these numbers are less than 4. So I'm actually going to shade in all this, and that's it. Erase that bit. Yep. Y is greater than -1, so again, there's no equal sign, so we're just going to dot that. Oops, pretend I did that nicer. greater than -1. The y values that are greater than -1 are things like 0, 1, 2, 3, 4. X is greater than 3. So now we're looking at x values. So 4 is greater than 3, so that means I will go over there. If you pick a different x value, like 2, you would say 2 is greater than 3. That's wrong. So you know that 2 is wrong. So if it's wrong, you don't want it in your solution set. Then you go to the other side, the right side of this inequality. Sorry, let me make those lines. And the rest of these are exactly the same as 1, 2, 3. The only difference is number 10 will have a solid line. So that will be x is equal to or less than -1. So it looks like this. And you have to figure out which side it goes on. Okay, moving on. Y is less than 3x plus 1. So here's what I'm going to do. I'm going to graph this line. I'm going to graph 3x plus 1. And I know it's a dashed line because there's no equal symbol. So start off at 1 because that's the y-intercept. The slope is 3, so up 3 over 1, up 3 over 1. I'm going to go backwards, down 3 over 1, down 3 over 1. And I'm going to make some dash marks because there's no equal sign. And it says pick a point that's not on the line. So I'm just going to pick 2, 0. 2, 0. And we're going to see if it's true, that means it's part of the solution. That means it's an answer. So 0 is less than 3 times 2 plus 1. Is 0 less than 7? Yes. So that means this is part of my answer. Now let me try testing -2 to show you guys also what I mean. -2, 0. So 0 is less than 3 times -2 plus 1. 0 less than -6 plus 1 is -5. Is 0 less than a negative number? No. So when it is false, when a point like this is false, then you must go to the other side of this line, which I already did, so that is correct. Equal to or greater than -x plus 1, so I'm just going to use decimals to make it faster. -x plus 1, your graph will look like this. Let's see here. Yeah, start at +1, slope is negative, which means down 1 over 1, down 1 over 1. So, and because there's an equal sign, that means my line will be solid. So I have 1, down 1 over 1, down 1 over 1, down 1 over 1. It's got to go have the same slope all the way through. And now it says y is greater than or equal to. So let's pick a point 0, -2. 0, -2. If it works, we are going to, if it is a solution, we are going to shade in the bottom half. If it is not a solution, we are going to shade the other half. So -2 is greater than or equal to 0, -0 plus 1. -2 is greater than or equal to 1. Is that true? Is a negative number greater than a positive number? No, it is not. So this is not a solution, and I got to go over here. Okay. Before you graph the rest of these, though, notice that 1 and 2, y was by itself. That must be the case for all these. So in this case, I would add, no, I'll subtract x. So I have y, negative y, don't forget that, oops, 2 minus x. Divide by a negative, but don't forget what happens to the symbol when you divide by a negative. It changes. So you have positive x, -1x divided by 1 is -1, is negative divided by negative is positive, positive divided by negative is a negative. So you start off here, go up 1 over 1 because the slope is 1, up 1 over 1, up 1 over 1. You make a dashed line, and then you have to figure out, I'll show you one more time. So, let's see. So our point to test will be 2, 4. If it's a solution, you shade that way. If it's not a solution, don't shade that way. So 4 is greater than 2 minus 2. 4 greater than 0. That's true. This is part of the solution. That's it. Don't forget, before you graph these, you have to make sure that y is by itself. So, minus x, and then you will divide by 2, everything by 2, so you'll get negative 1/2 x plus 2. That's number 17. Y is equal to or greater than negative x minus 3. And then you're going to divide everything by 3, so you'll say y is greater than 2 plus 2/3 x, which is the same thing as 2/3 x plus 2. So now I know this is my y-intercept, this is my rise over run up 2 over 3, and I can graph it using that information. A store sells digital cameras and cell phones. The store makes a $100 profit and a $50 on each digital camera X and a $50 profit on the sale of each cell phone Y. The store wants to make a profit of at least $300. So as long as they hit the 300 mark, so if they sell $300 worth of digital cameras or $300 worth of cell phones, that's good. That's how many is that? 3 digital cameras and 6 cell phones individually, separately. Write and graph an inequality that represents how many, let's see, so 100x plus 50y must be, at least means you could hit that number or you could go higher. So 100x plus 50y have to be greater than 300. So here and here. And let's see here, write and graph an inequality. So I'm going to graph this. It says greater than 300. So, and if you just look at it, like, think about it. Oh, if I'm selling more digital cameras or more cell phones, am I making more profit or less? You're making more. So if this line is hitting 300, everything over here is more than $300 worth of profit. Identify and interpret 2 solutions. So we could just pick any 2 random spots on this, and I'll make it green so it's nice and distinct. So we have 3, 9 and 7, 2. I'm gonna write in black so it's not annoying. Sorry. 3, 9 is a solution if the store sells 3 cameras and 9 cell phones. The total profit will be 300 plus 450, 750. 7, 2 is also a solution if this sells 7 cameras and 2 cell phones. The total profit will be 700 plus 100 is 800. Alright guys, so that's graphing inequalities. Remember, really, you're essentially graphing a line like the same as an equal sign. You just have to decide whether it's dotted or solid. If there is no equal symbol under the inequality symbol, then it must be dotted. If there is an equal line, then it must be solid. And check your solutions to decide which way to graph or shade in. If you have any questions, make sure you ask your teacher or let me know.